Hi everybody, my name is Jesse Bishop. I'm a program manager on the Windows XAML team. I've been working on XAML platforms for the last few years, and one of the things I'm most excited to be able to talk about now in Windows 8 is the ability to combine XAML and DirectX. So this is one of my favorite new features. So I'm going to talk a little bit about how it works and how you can use it for your apps. So I know Tim talked a little bit earlier today about XAML in general, but I just wanted to do a quick recap here. So basically, XAML in Windows 8 is your Metro-style UI framework. So it gives you all the great stuff like built-in custom controls, user controls, templating. It also gives you layout, styling, data binding, media, animation, so all these like great UI framework type stuff. But I also want to talk a little bit about performance. So this is something that we put a lot of work into for Windows 8 in XAML. So we've done a lot of work to be able to leverage hardware now being an OS component, and also do things like independent animations where we can actually take animations that you've defined in XAML and run them on a separate thread to take advantage of hardware and make sure that no matter what kind of processing you're doing on the UI thread, we can still have these smooth 60 frames per second animations when you're animating stuff around the screen. And we've also done a lot of work around fast rendering and composition. So I guess the key thing I want to say here is you don't need to go think about DirectX because you might want great performance in your apps. XAML is absolutely able to do that in Windows 8. So DirectX in Windows 8 is, however, your graphics solution. So really everything in Windows 8 is built around DirectX, all the way from the hardware to the OS to the UI frameworks like XAML and HTML, JavaScript. These are all built on DirectX. So this is really your low-level graphics framework. The only issue with this is you have to make a trade-off between the control and complexity you get with this. Because it's more difficult to use DirectX than it is to use a UI framework, obviously. So it's also more work to align with the Metro style guidelines. So Chaz had talked a little bit earlier about how you have to create visuals for your app bars and things like that to sort of fit with the Metro style theme, which you get for free in XAML. There we go. So the way I like to think about the combination of these two things is really the idea of this rich UI plus real-time graphics. And so I'm happy to say now in the consumer preview of Windows 8, you can actually combine these two things. So you really get the best of both worlds with XAML and DirectX. You get the sort of control model, the animations, the HTML hosting, the design time experience in Visual Studio and Blend you get with XAML with the highest performance possible rendering you can get in Windows 8 with DirectX, as well as direct device access, image effects, all the very complex, meaty stuff you can do with Direct2D and Direct3D. So I wanted to talk a little bit about times when you might want to do this. When do you really want to combine this rich UI with these real-time graphics with XAML and DirectX? So there's a few example scenarios here. You can think about things like visual design, modeling, creativity apps. This might be CAD and CAM tools. It might be 3D modeling, even something like a painting app where you have UI, but you also want this sort of real-time, high-performance graphics. Complex image processing, even something like large documents and maps where you might have like really large-scale vector content or image content, like say a world map that you can pan and zoom around, and you really want to have high-performance rendering for that. You might want DirectX, but you still have UI assets around it, like your search bar and things like that XAML lends itself well to. And then finally, there's a class of apps like simulations, say physics sims, or industrial modeling, as well as games where you really have a huge focus on DirectX rendering, but you still might have some XAML UI for something as simple as an app bar. So what we found is that a one-size-fits-all approach really wasn't sufficient for this broad range of scenarios. So what we've done is actually add 3 new XAML types, which each target a different type of need. So the first one being this first set of scenarios I talked about here, where you really have primarily XAML UI, but you might want to add little sort of islands of DirectX content into it, and then sort of mix the two and composite them together. The second one is times when you might have large-scale DirectX graphics. So this is, again, very large-scale vector image content that you might want to be able to scroll and zoom, something like a map or a document viewer or a PDF viewer, things like that. But they still have some sort of UI around them to do navigation and things like that. And then finally, the third category was very DirectX-focused applications that have minimal UI. So you might think of like a game with a settings menu or an overlay for the game menu, things like that. So in terms of all 3 of these interop approaches, some of the things that we wanted to keep in mind were the ease of integration. So we really wanted to have a way to do easy composition of XAML and DirectX using a familiar model. We didn't want to introduce some new third thing that you have to learn in order to do this. So if you have DirectX background or you have XAML background, it should look really familiar to be able to combine the two together. We also wanted to make sure that we have all the functionality of both XAML and DirectX. We didn't want to limit it and have it be some subset. So really it is just merging the two together in the same app. In terms of performance, we wanted to make sure that you still were able to get the low latency input and interactivity that you would expect from either of these frameworks. We didn't want to have a high overhead for mixing them together. We also allow incremental rendering for both the XAML and DirectX content. So if you want to update, say, just part of the screen, if you have a DirectX surface and you just need to redraw something in the corner, you don't have to redraw the entire thing. So that's another good way to increase performance of your app. And then finally, these do use different rendering modes. If you think in graphics terms, you can say that XAML is sort of a retained mode system, where all of the visuals on the screen, like your buttons, are all composite controls with text and so on. And these are all retained mode, meaning they have sort of an object tree that backs them with properties and methods and events and all that kind of stuff. And then there's DirectX, which is more of an immediate mode rendering solution. So you're just basically drawing stuff onto the screen. And it's not necessarily a button class that has those properties and methods and events attached to it. It's just some rectangles you've drawn. So using these two modes together, we wanted to keep the overhead for that low. Finally, C++ only. So XAML code behind, again, can be managed with C# or VB. It's WinRT. It's projected to these different languages. But DirectX, as you've heard, is C++ only unless you're using wrappers. So in this world, it's still basically exactly the same. If you want to interrupt with DirectX, you still have to do this in C++, and I'll show you how. Basically, the way you do it is you have to query for the backing native interfaces using that query interface ability you have that I think Herb had talked about earlier today. This allows you to get basically the backing interop native interface for the XAML WinRT types. So looking at that first set of scenarios we wanted to enable, this is the ability to take DirectX graphics and sort of integrate them into a primarily XAML UI. So the way we've enabled this is adding this new type called surface image source. So if you're familiar with XAML at all, this is just like any other regular XAML image source type. There are other ones that allow you to draw images and use them to paint objects and so on. So what this allows you to do is basically use DirectX, Direct2D, and Direct3D to use to basically draw any content to the surface and then use it to fill any XAML element that takes a brush. So you can say take an ellipse or a rectangle or an image and actually use DirectX to paint directly onto those types in XAML. So the way this works is the framework supplies you with a DX surface, and then you just draw to it whatever you want to update content. So it'll actually take the rasterized version of whatever you've drawn in DirectX and then use that as sort of like an image brush that you can then use to paint content. So you can update this every frame if you want. And as long as your code is fast, you can update this at 60 frames per second. Or you can just leave it as sort of a persistent brush that you can just paint once and then you can use everywhere in XAML. So that's sort of one of these integration points between this retained mode rendering you get with XAML and then the immediate mode you get with DirectX. You can actually keep your DirectX content. You don't need to redraw it every frame. So this is a little bit conceptually similar to the WPF 3D image type, if anyone's, D3D image type, if anyone's familiar with that in the past. But it's definitely been made easier to use and certainly more powerful than that was. It had a few restrictions. One of the things was this airspace concept that we talked about where if it's in, say, a separate HWind or something like that, you can't basically have XAML content and then DX content and XAML content on top. Well, now you can. All those restrictions are gone away, so you can actually arbitrarily combine these in any way you want to. So you can actually take, say, a rectangle that you use DirectX to draw content into, and then you can apply XAML Z-indexing and transforms and animations, all these different XAML concepts to that DirectX surface, and it will composite seamlessly with the rest of your XAML UI. So you can see at the bottom here, there's just a quick example of how this might work at a very high level. So you can actually define your ellipse type in XAML markup. You can see here I've named it ellipse1, which will create an instance of ellipse and name it ellipse1. I've applied like a black stroke to it, so it'll draw a black outline around it, and then just I've given it a height and width. Then in your XAML code behind, so this could actually be C# or C++ or anything, you can then create an image brush and set the source of that brush to be a surface image source, which is this new XAML type that you can draw DX content into. And then you basically just set that brush as the fill of an ellipse. Now you could have 100 ellipses and set the fill of all of them to the same shared brush, and it will actually go and update all of them. So that's sort of the way you can use this DX content in a reusable manner across different XAML elements. So just to look a little bit at the definition of surface image source and how you use it, the first thing you may notice is the name doesn't quite match up here. So rather than the surface image source type being used directly, because again, XAML is all projected into different languages, and DirectX is C++ only. What we've done is added this backing native interface that you have to query for from your XAML type. So you can actually take a surface image source type in your code behind, and then you query it for this interface, and this gives you access to all of the interrupt methods in C++. So the very first one is set device. So you call this basically when you've created it, and you pass in a DXGI device. So you actually create your own DirectX device to do your rendering. And so all of your drawing calls will be done through this device, and when the framework allocates a surface for you, it will actually be done on this device. So all of your drawing will go through this. This can be a hardware device or a software device, and it supports all the concepts of feature levels or using warp that we talked about with DirectX earlier. The second method is begin draw. So you call this whenever you actually want to go and update this surface. So you, again, don't have to do this every frame, but you can if you want to. Basically, whenever you need to draw an update because something's moved or you want to refresh your content, you can go and call this method, and it will update any brushes that have been derived from this surface. So you pass in an update rect, and what this does again is give you the ability to do that incremental rendering I talked about, where if you only want to update a specific part of the surface, you can do that. You don't have to necessarily update the entire thing, just as a performance benefit. This returns you basically a DXGI surface that you get back that the framework has created and allocated for you, and then all of your drawing through your device will then be done to this surface to have the framework take it and consume it and present it on the screen for you. And then finally, it also returns an offset as a third parameter. So when you get this surface back, it doesn't necessarily match one-to-one with the dimensions of the update rect you've passed in. The reason for that is we do some optimizations internally so that we can sort of combine these updates together and package them with the rest of the XAML textures that we're going to upload to the GPU to do all of the presenting on the screen. So this offset is actually necessary to tell you where in that surface to start drawing. Again, this is just done as a performance benefit to help your app be faster. So the easiest way to account for this is often to just basically apply a transform to where you're drawing, just to make sure you take into account this offset when you're drawing into the surface. And then finally, end draw. So all of your DX drawing calls basically get sandwiched between these begin draw and end draw pairs. That allows you to sort of batch them together, again, just to get some performance benefit. So as soon as you're done drawing updates to this surface that you have returned from begin draw, you can then call end draw. We will take that surface and composite it with the rest of the XAML UI and then present it on the screen for you. So I'll just show a quick demo of how this works. Okay, so you can see I have a little project here on the side. And so I have two components here. The first one is actually just a regular XAML application. So I've created a blank application from the blank XAML template that ships with VS. And if I take a look at the page's markup here, you can just see I have a few elements. I have a couple buttons just to control what I'm doing. And then I have here an image called image1 and an ellipse called ellipse1. So this is really just define the UI of my simple little app here. It's not anything very interesting or complex, but you can see, again, I have an image here. You can't really see it because I haven't set a source yet. And then I have this ellipse, which is just drawing white right now. So I've defined my UI in markup, and then if I go into the code behind here, you can actually see what happens. So if I click one of those buttons that was at the top there, I've actually set, so here I've actually created my image sources, and I'll show you those in a second. So these are actually derived from surface image source. So I've just stored them away inside class variables here. And then when I click one of those buttons, I actually can set the source of an image directly to this surface image source. So it doesn't necessarily have to go through a brush. If you have an image control, it actually acts like an image. You can just set its source directly to this. And then if you want to fill other elements, like say this ellipse 1 that I had created in markup, I have to create a brush, and then I set the source of that brush to be the surface image source, and then I can use it to fill multiple elements. And then finally, what I've done here is I've called begin draw. So this will map, I'll show you in a second, to the surface image source begin draw call. I've cleared it with this color, and then I've just drawn a bunch of rectangles on it. And finally, I call end draw just to say I'm done drawing. So if I compile and run this, you can actually see this is using DirectX just to draw a bunch of rectangles. I'll show the code for this in a second. And then used it to fill both this image control here, and then, oh, okay, we're actually a little bit cut off, but there's some buttons up at the top I'm clicking here to set the source. And then there's this ellipse, which is actually painted with the same thing. So you can see this gets full composition with XAML. These are drawn in DirectX, but I still get the z-indexing behavior. I can still drag this around by applying a XAML transform to it. And if I line these up just right, you can actually see these are lining up because I've used the exact same image source drawing DX content to draw both of these, the fill for both of these elements. So let's take a look at the source for that. So what I've done here is I've actually created a separate WinRT component. So this allows me to basically package all of my DirectX calls inside this, this WinRT component that I can then go and use in any Metro app, like any XAML app, say like a C# app, a VB app, or a C++ app as it is in this case. So by packaging this, you get a lot of reusability, and you can actually take these surface image source derived types you've created and sort of ship that to people as a component they can use, whether it's simply to create a really fancy chart control or to do a full DirectX rendering engine. I can actually create this separate component and then ship that to people, and they can use it inside C# if they want to. So you can see the definition of this here. I've actually derived from surface image source just to make it a little bit easier, and again, wrap all of that DirectX interop inside this component so that I can then go and use it from other types of apps that aren't necessarily C++. Then I have a couple begin draw methods, an end draw method, and then you remember these two methods that I had called clear and fill solid rect. So I'll show the implementation of those in a second, but they basically just use direct2d to go and draw some rectangles. And then I have a few just variables to keep track of my state. So you can see here I'm using this iSurface image source native, which again is the backing native COM interface for the XAML surface image source type, and it allows access to all of those DirectX drawing methods. Then finally I have my D3D device and the context, and then the same for D2D, so this is how I'm going to do my drawing. So taking a look at the implementation here, again, I've just stored away the dimensions. I've called into my base constructor, and then I'm just going to create the resources I need to start drawing. So this is where I actually query for that backing native iSurface image source native interface. So I've actually just cast this because, again, I'm deriving directly from the surface image source WinRT type. I've cast this as an IUnknown just to get access to the query interface method, and then I've gone and basically stored a reference to its backing interface into my msys native variable here. And this is just a macro that basically lets me go and get the ID for this interface from the type of this variable. So after I've done that, this looks a lot like any other DirectX application. I can basically create a device here with the same method. In this case, I've decided to create a hardware device. You can also use Warp to create a software device and pick your target feature level to do testing with, or just to use software rendering in general, depending on the hardware you're targeting. And then basically this is very similar to any other D2D app that would be created for a core window application. I've created my D2D device context, everything I need to do to get set up. And then here's this method where I call setDevice on the surface image source native interface to basically associate this D3D device that I've created with the surface image source. So now any drawing calls that go through this device will get painted to this surface, and I can allocate render targets and all that kind of stuff onto this surface using this device. So in my begin draw method here, which again I've exposed as a WinRT interface off my component so I can consume it from any other language, it basically just calls the surface image source native equivalent begin draw method. And I've passed in the update rect, which in this case I'm just updating the entire thing. And I get back a surface and an offset. So I have a little bit of error checking to see if I need to recreate the device because maybe it TDR'd or something like that. Then I can create a render target from that. I can set it as the target for my Direct2D drawing context. And then I can basically just start drawing with Direct2D. And this shows how to take into account the offset. Basically, I've just applied a clip and a transform that takes into account the offset parameter that gets passed back from begin draw and tells me where I'm going to start drawing inside that surface that begin draw has returned to me. So as soon as I've done that, I can then use any arbitrary Direct2D or 3D drawing methods I want. So in this case, I've just called clear on the context. So this will, again, because I've applied that clip and transform, will automatically scope itself to just clear the area of the actual surface image source that I want to update. And then I've called this fill solid rect method. Again, this being a WinRT call that I've just exposed. So it will, again, be consumable from any type of app. And internally, I just use a Direct2D brush to basically fill a rectangle. So it's very simple in this case, but it really shows how easy it is to basically use Direct2D to draw content inside a XAML app. And this could similarly be Direct3D just as easily. So if I run this again, I'm going to set an animated source. So what I'm doing here is basically just every frame that I'm producing XAML content, I'm actually going and updating the position of a bunch of those Direct2D rectangles. And so again, if I line these up just right, you can see these are driven off the exact same surface image source. So anything that gets painted with a brush that's using that image source as a source, I will go in and update everything on the screen that's done with that. And I can actually still drag this around. It's just manipulating a XAML transform. You get the full Z-index support and all of this ability to composite your XAML content, but with DirectX drawing backing it, essentially. Okay, so let's talk about the second type of application that I mentioned earlier. So this is a time when you might have really large-scale DirectX graphics. So again, maps, schematics. You might have your 1,000-page document, which you probably don't want to draw in XAML just because you don't want to have this huge element tree and have to keep track of everything and be redrawing it all the time. But you still want to have some UI, and ideally we want to use XAML for that because it's a lot easier to use text boxes and app bars and things in XAML and be able to define those in markup and use all the good stuff XAML gives you and be able to design that UI inside Blend and Visual Studio. So the way we've done this is with this virtual surface image source type. So this extends surface image source derives directly from the interface to support the concept of virtualization. So this is to support huge virtualized areas. Virtualized here meaning that you don't necessarily want to draw everything in the entire surface at the same time. You really only want to draw what you need to for what's visible on the screen at any given time, maybe plus some extra so you can do buffering so the scrolling is smooth. So this is really useful when content is larger than what fits on the screen. It could potentially be much larger, so you might have a million pixel surface or something, and you want to be able to draw just what you need to at any given time. So the way we do this is with a tiling and callback approach. So we split our content into rectangular regions that we have just called tiles. And the framework actually requests updates from your app when it needs to be able to draw one of these regions, again, because it's coming onto the screen for whatever reason. So the performance characteristics of this type are actually tuned specifically for large content again. So this is, again, your giant maps and documents and things like that. So these are times when you might want to integrate with the XAML scroll viewer control, which gives you the scrolling and zooming behavior. And anything that uses a virtual surface image source becomes smart enough to know when you're actually scrolling inside a scroll viewer and will actually request updates on your behalf and sort of handle all that logic of figuring out what's visible at any given time for you. It also maintains a smart cache of these tiles. So if you scroll something out of view and then back again, it won't necessarily have to re-request that stuff that you've already drawn because it will actually cache it and keep it around. And it will reuse those tiles over time if it needs to because you've, say, scrolled all the way to the bottom of something really long. It doesn't necessarily think you need the stuff at the top. So it'll sort of keep track of all of that for you, and it won't necessarily make you redraw things that you've already drawn. So these are just a couple quick examples of what that might look like. So in the top left here, this is a sample app that's actually online on the Dev Center. You can download and look at the source for it. And it's just sort of a magazine app that's doing all of its drawing in Direct2D, but it uses a virtual surface image source to basically handle the virtualization of content for you so that when you're scrolling around, it will go in and request only the areas it needs to draw for you. And as for the other one, if you look at a map control, you can see how this would lend itself very well to that concept. So if you imagine this being divided again into these rectangular regions, as you scroll around, you can just load the tiles that you need to. And so that's all handled seamlessly behind the scenes for you. When you get this callback I'll show you in a second, you can just basically draw whatever is in these tiles that it's said you need, and it will handle the positioning and arranging for you as well as all of the scrolling behavior. So the definition for this, again, it's one of these backing native COM interfaces that you have to query for from the XAML virtual surface image source type. And it inherits directly from my surface image source native. So it still has those same begin draw and end draw semantics. If you just want to update something that's on the screen at any given time, you can just do that through the normal surface image source way. But we've added a few things to make this sort of tiling virtualization concept much easier. So the first thing we've added is this iVirtual Surface Updates callback native interface. And so it has an updates needed method. And so you actually register an implementation of this as a callback. And so the framework will call this updates needed method that you implement whenever it needs to draw one of those tiles. So whenever you get that callback, you can then call getUpdateRects and getUpdateRectCount. And it will tell you, it's basically a list of those rects inside your overall surface that you need to draw just to make sure that it's shown on the screen. And then finally, we have some extra helper methods. One of the cool ones is invalidate. So this actually allows you to manually invalidate one of these regions of DirectX content. And so you don't have to necessarily keep track of what's on screen at any given time. You can just say, I want to invalidate this region. And the next time it has to be refreshed, it'll make sure that you get an updates needed callback for that rectangle if it's scrolled back into view. So this is especially useful for things that are off screen because you can just invalidate it and forget about it until it actually comes back in again. Whereas if something's visible on the screen right now, you could either do this or you could just, again, directly use that begin draw, end draw pair that you get with surface image source. So just to recap on usage for this, the first thing you do is you register, obviously, that updates needed callback. So this will get called whenever you need to update the surface. You then get a list of the tiles that you'll need to update with the getUpdateRects method. And finally, you just draw updates using the same begin draw, end draw approach that you had with surface image source. And if a region needs an update, you can invalidate it, especially for off-screen content. And finally, you can dynamically resize these as well. So you can actually at any time get the visible region to see what's there. And if you need to actually resize it or you want to resize the total size of the surface, including everything that's off-screen, you can make it bigger or smaller, and it'll figure out what it needs to do to make that happen for you. Okay. Let's talk about the third one. So these are a category of apps that are basically DirectX focused with minimal UI. So again, this is things like games, especially, where a lot of the time it'll be mostly the graphics you're drawing to get your game up and running, but you might have some minimal UI, like we had said in an earlier talk, even something like an app bar. You might want to use XAML to be able to draw these. So what we've done for this set of scenarios is add this new swap chain background panel type. So this is basically very analogous to a full-screen DirectX app with a XAML overlay. So any XAML content basically gets drawn on top of it. And the XAML swap chain background panel type inherits from grid. So this allows you to do easy layout positioning of all of the XAML content. So if you have, say, a menu snapped to the side, or you have something in the middle of the screen, it allows you to do very easy layout and keep track of all of your XAML children. So the special thing about this one is it actually allows you full control of the DirectX surface. And this allows you especially low latency interaction and control of your presentation timing. So with surface image source and virtual surface image source, we would actually take that surface that we allocated for you, and then we would composite it with the rest of the XAML UI. And so there's some extra overhead involved because we need to go and figure out the Z indexing and apply the XAML transforms and all of that for you. But in this case, because it's just a full screen swap chain that you've created, you can actually go in and present to it however you want. So it's not even necessarily tied to the XAML UI thread in this case, although it can be. So you can actually just get full control over how you render to this. And the XAML and DirectX are basically separate layers, so you can update them independently. So this does have some trade-offs, obviously. So you get the more control with this because you are basically owning the DirectX swap chain. Swap chain, for those who don't know, is basically just a graphics concept for a memory buffer that defines what you're going to show on the screen at some point. So you can basically create those yourself and control them with this method, whereas with the surface image source and its derived virtual type, it actually will not allow you to do that. The XAML framework will handle the compositing and all of that for you. So with this type, it's full screen only. It has to be the root element of application. Again, all the XAML content goes on top. It can't ever be behind. So the interface for this is actually very simple. We're just trying to get out of your way with this one and basically let you do whatever you want to do. So the native interface, again, which you query for from the swap chain background panel XAML type, just has one method, which is set swap chain. So you create your own swap chain and handle presentation of it entirely yourself. And basically this method just allows you to associate the XAML swap chain background panel type with your swap chain. So this is a little bit different than the core window approach, where you would actually tie the window to the swap chain. So here you're actually tying the swap chain to the XAML type so that we know that you're going to be presenting stuff there. So using this, you can actually just define this in XAML just like you would with any other XAML type. So you can create a swap chain background panel in your markup. You define this as a class. You can name it. You can apply event handlers to it, just like you would any other XAML element, and then you can add children. So here we've just added a simple text block to say, here's some XAML content. You can put anything you want in here. So this fully supports all XAML content, and it will all get drawn on top of this swap chain background panel. So in order to create the swap chain, it's a little bit different than it would be with a core window app, but it's very actually similar. So we've added this new method called create swap chain for composition. So you need to call this just to say that to the framework that this is a swap chain that we're going to need to composite with other XAML content that sits on top, whereas with just a pure DirectX app, you would say create swap chain for core window because you're going to be associating with a core window rather than a XAML swap chain background panel. Finally, again, we need to get access to that native backing interface of the swap chain panel type, so we can just, again, query interface for it. And this just shows a recap of how to do that. This is pretty much all you need to do. And then you can call set swap chain. So again, you just do this usually just once at the start when you're starting up, just to associate these two together. So a few tips for this one. When you're adding XAML children, you want to be mindful of the overdraw. So you really want to scope your XAML element sizes to just the area they need to display. So you don't want to always be creating a full screen XAML overlay just because you're going to be paying some cost to basically composite the XAML and the DirectX content you've drawn together. So you want to scope the size of the XAML to just what it needs to display. And we've actually added a debug method that lets you visualize this. So if you set this is overdraw heat map enabled property to true, it will replace all of your XAML children with translucent rectangles that sort of like stack up, and you can see where they've been blending together. So especially on devices that don't have quite the hardware power, things like tablets, you really want to be aware of how much work you're asking the GPU to do. So this is a good way to sort of visualize that and make sure that you're scoping the size of your XAML elements down to just what you need. Finally, when you're drawing content, you want to be able to create a landscape swap chain and just apply rotation as needed. This is just a performance tip. It's the best way to do it. And finally, composition target rendering event. So this is actually a callback that the XAML framework gives you to be able to do basically real-time updates on the XAML UI thread. So every time the XAML UI thread is going to produce a frame to display on the screen. So by default, hopefully this should run at 60 FPS, assuming you're not doing a ton of synchronous work on the XAML UI thread. You'll get this callback every single frame. So again, you can go at 60 frames a second and sync with the vertical refresh rate of your monitor and use this as sort of a callback that lets you synchronize updates between the XAML and the DirectX content. So again, you don't have to use this to draw DirectX content. You can present however you want. The only issue is that if you have XAML content on top that you want to update at the same time, you need to make sure that you're on the right thread. So any updates, again, to XAML content have to be done on the UI thread. So this is just one way to keep those in synchrony, essentially. But you definitely can also queue work, asynchronous work, like DirectX, like long computation and render tasks. You can queue those on a separate thread or using a separate device, and that absolutely all works. Again, we just want to get out of your way with this one and let you do whatever you would normally do with the DirectX application, but allow you to add XAML UI on top. In terms of input handling, again, you can still use the core window events that you would in a DirectX application, but it's probably a lot easier to just wire up the event handlers like I showed on a previous slide in XAML to the actual swap chain background panel element. And so this just basically does all of the layering for you and calculating the Z index. So say you have a XAML button on top of your game and you click that button. You want to make sure that the button in XAML is the only one that handles the event, and this will actually prevent the input from bubbling out to the swap chain panel, making you think you did something else in your game on top of that. So basically all of the hit testing is done for you if you use XAML events. The only thing we don't do is, again, X input for controllers in XAML. So if you have things like, in a previous talk, Chaz had mentioned using like a game controller. So if you want to do things like that, you can still have access to X input for audio as well. If you're doing real-time audio effects, you still have X audio. So anything that's sort of more game-oriented, like these polling APIs or the real-time sound, you can absolutely still use those. And you don't want to necessarily use XAML for those because that's really not what it's designed for. Okay, so this is just a recap again of the different composition modes for these two approaches. On the left, we have the swap chain background panel. So this is just really trying to stress that, again, your DirectX content is sort of sitting behind your XAML, if you want to think of it that way. And then any XAML you add is really added as an overlay layer on top of that. And we've done work to only blend the XAML area that's actually, you've actually defined in your XAML layout. So you don't want to create a full screen XAML overlay. You just want to have these regions of XAML wherever you actually need to draw content. And this is done for you if you just say add an app bar. It will automatically size things for you. But if you have some persistent content that's always on the screen, you want to make sure that you just size it down to just the regions you need to draw. And this is in contrast with the surface image source and virtual surface image source model, which is really a fully integrated composition model where you can have DirectX and XAML content fully interleaved in the same app, and you can actually compose them any way you want, just as you would with any other XAML element. So I'll show a quick demo of the swap chain background panel. I think you've actually seen a few of these today, but we can go into a little bit more detail now because you actually know what it is. So this is another sample that's actually online in the SDK. You can see this on the Dev Center. You can download it and look at the source. So there's actually a core window version of this as well as a XAML interop version. So you can see this is actually not just a 2D app. This is a fully 3D DirectX shooting game that the Direct3D team has released. So there's a core window version of this, and this is just a port to XAML. So this is actually really easy to get up and running in XAML. Again, the main work you have to do is just making sure that you're creating the right type of swap chain with the create swap chain for composition method, and rather than using the core window version. And then there's a little bit of work to basically take the iframework view out and then use the XAML app object to do sort of your window hookup. So if you contrast these two, you can again see both the XAML version and the core window version, and then just see how little work you really need to do to be able to move between these two. So if you actually want to add XAML UI to an existing DirectX application, it's very easy to do. The only point at which there might be more work is if you want to take these assets that you've already had in DirectX, like say your overlays, your text, and then recreate them in XAML instead, which if you're starting from scratch, you probably want to actually start there because again, it's a lot easier to create controls and these sort of elements in XAML than it is to use DirectX. So again, I won't go into too much detail here, but you can see you have a XAML app object, so this would replace the iframework view version, and it does the hookup for your initialization and your launching and everything like that, and allows you to basically hook into those activation events in a XAML way, just like you would with any other XAML app. And then inside your page, you just define a swap chain background panel element, and then you go and query for its backing native interface, and then you can just start drawing to it immediately. So this is just really to show that you're definitely not restricted to just sort of these 2D experiences. This is full DirectX and XAML integration where you can use Direct3D to do high performance 3D drawing with low latency easily well enough to create these sort of FPS type games. So again, just to recap, so we've added these 3 new approaches to combine XAML and DirectX in your applications, surface image source, the virtualizing version, and then the swap chain background panel. And just to point out as well, you can totally mix and match these. So if you have a swap chain background panel, again, with this one, you can only have one per app because it's always in the background. You can then have surface image source backed content inside the XAML overlays that go on top of that. So you can use all of these approaches. If you have, say, your game in a swap chain background panel, and then you might have a little mini map in the corner, and you want to use a virtualizing surface image source for that, you can definitely do that as well. But you should definitely think about the scenario you're targeting to figure out which one of these interop APIs you want to use for any given scenario. So in many cases, actually, XAML alone will work great. Again, we put a lot of stress on performance and being able to work well across a broad range of devices with Windows 8, just using XAML. So you can get pretty performant retain mode graphics with smooth 60 frames per second animations that are totally independent of the UI thread. And in a lot of cases, that will really work great. But if you really do need the power of DirectX for your real-time graphics, you have these 3 options. So surface image source, if you need the close integration with XAML, composition at a per element level. Then you have the virtualizing version if you're doing scrolling and zooming of large-scale content within that. And then finally, we have the swap chain background panel, which is really close to a native full-screen DirectX application, but with XAML UI on top. Even if it's as minimal as an app bar, you can definitely use XAML to be able to create Metro-style UI without having to implement it from scratch in DirectX. So again, just a couple things about structuring your app for all of these. You want to define your, again, Metro-style UI using XAML whenever possible, just because it's easier, and there's tools around it with Blend and Visual Studio. It's much easier than trying to do this yourself in a DirectX app. You also want to use your XAML code behind for input processing, doing those view state changes, things like that, just because there's a lot of work already done for you as a framework. It's not a low-level API. It's a high-level UI framework that has a lot of these concepts already wrapped up and packaged nicely for you. And finally, if you wrap your interop code in a native WinRT component, this actually allows it to be used for managed code as well. So you saw with the very first demo with the surface image source, I actually created a WinRT component, and then I could use that in a C# app or a C++ app, and it makes it quite nicely reusable, and it allows you to wrap all of that sort of DirectX interop inside a component and sort of abstract that away from the user. So I just added a couple of resources here at the end. There's a blog post which has some details on this online on the Windows Application Development blog, which I also encourage everybody to read. It has a lot of great stuff about building apps for Windows 8. There's also an overview topic on MSDN for DirectX and XAML interop. And then those samples I showed you can actually go and download. Again, here's a link to the 3D shooting game that I'd shown for that. So that's the XAML version. There's also a core window version, and they share most of the code, so you can really see how easy it is to move between them. And then there's a couple other sample apps you can also download and take a look at, including the magazine sample for the virtualizing surface image source. All right, thanks. I guess we can take some questions.